Hello everyone, I'm Kodem. Today we will talk about spinal nerves. It's very important topic, and I will mention about most higher things and what you must know. Okay, let's look this image. This is spinal cord. Here is spinal cord, and from spinal cord comes both sides, from here and from here, dorsal root and ventral root, and dorsal root, these two roots, and it creates spinal nerve. Actual spinal nerve is very short, about 1 centimeter. This section is only spinal nerve. After this short distance, it branches. It branches to rami, ventral ramus, and dorsal ramus. And it's very interesting. Ventral ramus is here and dorsal here. They are same content. In both of them there is sensory fibers, red here, this red, sensory fibers, and motor fibers too, this blue here, motor fibers. And the same is here in the ventral ramus too. Sensory like this, sensory fibers, and in blue, motor fibers. Both these branches have the same content. Both are mixed nerves. So spinal nerve is mixed nerve. It contains as motor fibers, also sensory fibers. Okay, this is important fact. A ventral ramus is much larger than dorsal ramus. Why are they exist, these two? Because they innervate different locations on the body, so they are two branches. But ventral ramus is much larger than dorsal ramus. Okay, another important fact is that here is in the root, its root, yellow is root. In the root here is dorsal root ganglia. This. What is ganglia? Ganglia is when neuron bodies are outside of the central nervous system, or outside a brain or spinal cord. This area is dorsal root ganglia. Here is neuron bodies, many neuron bodies, and it's dorsal root ganglia. And here is ventral root ganglia. Okay, I think it's easy, and you must know that spinal nerve is very short, about 1 centimeter. It then branches. It has two branches. One is dorsal ramus. Another is ventral ramus. Ventral ramus are much larger. They have both same content. they contain the same fibers. They are not different in their content. They are different their size and location. Okay, here is, and very simply we can say what location are innervated by dorsal ramus and ventral ramus. Dorsal ramus innervates skin of back and dorsal neck, deep intrinsic back muscles. What is blue? It's posterior view of human, and this area is innervated by this area is innervated by dorsal ramus, and all other is innervated by ventral ramus. Skin, anterolateral trunk and limbs, skeletal muscles, and anterolateral trunk and limbs. Very easy, I think. And human had 31 spinal nerves, 31 pair of spinal nerves, and they innervate certain dermatomes of the skin and muscles, and you can easily find them in your any medical book. So and why it is clinically important, because when there is a problem or compression of spinal nerve, you can easily determine which nerve it is, and symptom location of these symptoms, and symptoms may be weakening muscles, muscle ache, okay, and difference between somatic and autonomic nervous system, also very important, because if you ask, most of people will tell you that difference between somatic and autonomic nervous system is that you can manage, and it's voluntary somatic nervous system, and autonomic is involuntary, but it is not true, because you know about muscle reflex. If you hit muscle, it will contract, and it's involuntary, but it's also controlled by somatic nervous system. So it is not right that somatic is voluntary and autonomic is involuntary. There is some true in this sentence, but it is not completely true. What is different? So somatic nervous system innervates skeletal muscles. It's very important. It innervates skeletal muscles. One neuron pathway means that from central nervous system to periphery and innervated organs or innervated skin, there is only one neuron, and its axon. A cell body always located in CNS. It means that cell body of this somatic fiber, nerve fiber, cell body always is in central nervous system, in brain or in spinal cord. Derived from a neural ectoderm. Always somatic nervous system is derived from neural ectoderm or neuroectoderm. Okay, and one neuron pathway means I want to paint it. Here is neuron. Let's say that Here's neuron. I'm not very good at paint, but imagine that it's neuron. And this neuron is located in brain. Okay, this section, and here is end organ, skin. It's somatic. And one neuron pathway. Here's one neuron, and there is another. There is no another neuron. This neuron innervates skin, and it's somatic. Muscle. That's not skin. Muscle, in this case. Okay, and there is only one neuron. There is no another neuron. But in autonomous nervous system, let's type it. Autonomous nervous system, there is two neuron pathway. Always. One neuron is in CNS, and it is connected another neuron which is located in periphery. And let's see this picture. It's located dorsal root ganglion here, or here, ventral root ganglion. It is located on in ganglions, and from it innervates end organ. For example, a smooth muscle. Here is two neuron pathway. One neuron and another neuron. And first neuron always is located in central nervous system, and another second neuron is always located in peripheral nervous system. Okay, I think it's very easy. You can remember it very easily. So it's somatic nervous system, one neuron pathway. Autonomous nervous system, two neuron pathway. Okay. Autonomous nervous system innervates cardiac muscle, smooth muscle, and glands. Cardiac muscle, smooth muscle, and glands. Two neuron pathway we already talked about. Second neuron body is peripheral nervous system. Second neuron body always in periphery, not in central nervous system. And the second neuron is originated from neural crest, not neuroectoderm, but neural crest. First neuron is originated from neural ectoderm, and second is from neural crest. Thank you for watching. Thank you for interesting. I think it will help you. Thank you so much. Please subscribe my channel, like my videos. You will help me at this way, and you will give me motivation for next better videos. Thank you very much. Bye.